So I'm sitting out here in Limestone County, Alabama, out here by just across the county line from Madison County along 565. And I saw this, I think this is called Indian Springs Road. I saw this neat summer single cell, multiple single cells, convective evolution, and just thought I'd talk about what I'm seeing a little bit. It's interesting. So, see if I can get my finger out here and illustrate what's going on. So what I'm seeing is this this anvil back here. This is the newer convection. The older convection. You can see the glaciated cloud tops. There, they look wispy. They're kind of dull. The edges are dull. That means the convection is older. Those are ice crystals up there. The cloud is largely composed of ice crystals, a little bit of supercooled liquid, but mostly ice crystals. Gives it that real raggedy look. But over here, of course, there's a rain shower, some precipitation fallout right there. That's probably becoming what we call an orphan anvil right here. This is the old thunderstorm top, old thunderstorm that is decaying. And over here you have new convective growth over here on the left, and that is the newest in a series of multi-cell towers that are going up there. And so really fascinating. I know it's not a whole lot to write home about, but a lot of times in these summer events you have to, make something to talk about. So I thought that was interesting. Of course, then you have your contrail up there at 30,000 feet from your commercial aircraft, more than likely. So really fascinating. So yeah, you have an orphan anvil here with decaying convection, precipitation fallout noted there, a new anvil, new towers going up on the left edge of that multiple single cell. You could call it multi-cell, but generally speaking, multi-cells are a little bit more organized than this. So multiple single cells, and maybe even a new tower going up over here. You can see the crisp convective growth, kind of similar to what you see over here. That would be unglaciated cloud cover or unglaciated convection. Brand new convection where it's composed of mostly, you have supercooled liquid, probably not much of that actually, it's probably not tall enough, but largely composed of just raindrops. And as you get rising, expanding, cooling, and condensing going on there to form cloud. As you get convection, so the convection from the afternoon, the diurnal daytime heating, causes it from solar insolation, incoming solar radiation, heats the ground, then you get rising, expanding, cooling, and condensing of the air and water vapor into cloud, and obviously then the rain. So really fascinating. It's beautiful. More than anything else, I just figured I'd show you the beautiful sights here out toward the Huntsville International Airport this evening. You never know what you're going to find on some of these summer evenings like this. So, and it looks to me almost like you can see some precipitation fallout way up here. You see that? Let me see if I can zoom in on that. Yeah, it's got that wispy look way up there. That's precipitation falling out of that. I doubt it's high enough for hail. That cascade that you see there of precipitation, believe it or not, let's see here. I don't know. There might be some hail in that way up there. It's probably up there at about, I'd say 15,000, 20,000 feet. That tower, it's growing, but it's not particularly tall at the moment, but it could have some ice in it higher up for sure. I'd say the freezing level today is probably, I don't know, it's probably around 500 millibars. These summer evenings, these summer days, typically, as the tropopause height grows taller with the northern hemispheric summer, I'd say it's probably between, 6 and 500 millibars up there, probably somewhere between 14 and 18,000 feet. So really deep tropical environments, you can have a freezing level above 500 millibars, upwards of 20,000 feet. So anyway, just wanted to show you guys this really cool summer evening. Y'all take it easy.